u substitution and, use the u version of the formula, right? Absolute value of u du is 1/2 u absolute value of u plus a constant. That's the version of my formula for just u. There is a topic in here that I have failed to discuss with you guys that is a standard topic for calculus that, we've danced around it, but we never actually did it. And I actually should spend about 10 minutes of class on it. So I think that's what I'll spend the rest of our time on here today. Yep.
Why did you change from 1 to 0 to 1 to 9?
Because the theorem of u substitution says when we make a u substitution, we have to change the integrand, the measure, and also the bounds if we have them. So if you got bounds, you got to change them. So 0 under the formula for u goes to -1. Right? When you plug in 0 into this, you get -1. When you plug in 1 into this, you get 2 times 1 minus 1, which is 1. So we have to change the bounds. Or you have to do the two-step thing, find the antiderivative, and then apply FTC2. All right. So the topic I'm thinking of here that I've neglected for you guys up to this point, and by the way, we can do more areas bounded by curves like tomorrow. I pushed the what I do? I pushed the lab back to after break, just so we won't have to bother. You guys can just focus on your homework. Won't be distracted by that last lab. So the last lab is just on the left, right, and midpoint sum rules, and also a little bit more about the fancier rules. I think I have a little bit about Simpson's rule and the trapezoid rule. Simpson's rule is when you use parabolas to cap off your approximating regions. But anyway, so I want to talk to you a little bit about the graph of y equals f of x, y equals f prime of x, and y equals f prime prime of x. So a popular question to ask calculus students is, here are 3 graphs. Okay, which one's the function, which one's the derivative function, and which one's the second derivative function? So let me give you an example of this. And I will do my best to be a good picture here. All right, so here we go. Y equals to f1 of x. All right. Y equals f2 of x. And hopefully we can see the blue. Well, you guys can see the blue. I'm not sure about folks at home. And then y equals to f3 of x. My bad. I messed it up. Sorry, I have to let me fix the blue one. Ah, curses. Let me try again. I'm going to try again. Okay, here we go. I'll start with F3. Then I'll do F2. And then I'll do F3. F1 rather. So let me put the, so you put f of x, f prime of x, and f prime prime of x in the correct blank. So here we go. f1 of x, f2 of x, f3 of x, so let me write down a sentence which is true, right? So for the graph y equals f of x, right? The slope positive implies y equals f prime of x greater than 0, right? The slope negative y equals f prime of x less than 0, right? So whatever graph you say is f of x, the f prime graph should be indicative of the slopes of the f graph, right? So what do you guys think? And the same thing goes for f prime, right? So like the graph of y equals f prime of x has a positive slope where f prime prime of x is positive, right? And it has negative slope. And what do I mean by the slope of a graph? The slope of a graph is where you think about drawing a tangent line, right? And you look at the sine of the slope of the tangent line to decide the slope of the graph, right? So what do you guys think? All right, now let's see if that works. So you say that that's f of x. So that would be the blue one, right? So where does this have negative slope? Whatever that point is right there, right? So exactly. So notice that this orange function is negative wherever the blue one is decreasing. And then the orange one is positive where the blue one is increasing. So I would add to your assumption that in fact f2 is f prime of x. Now if we're right so far, you're kind of forced to put the third one, right? So how about that? Now what's the slope of y equals f2? Well, it's a positive slope, right? And it's constant everywhere, right? Because it's a line. And so apparently, there you go. That must be f prime prime of x. f1 must be f prime prime of x. So what's an important distinction between this problem and other problems we've worked is there's no formula given, right? Basically, this kind of problem starts with you being given a graph and then asking you to discern which one's the function, which one's the derivative, which one's the second derivative. Another way to ask this question is, here's a graph of 3 functions of time. Which one's the position, which one's the velocity, which one's the acceleration? Same song and dance. I'll try to give you another one of these in other days that's more complicated, but I think I wanted to give you a simple example to start with because I personally found these problems very challenging as a calculus student, But, and sometimes sometimes some calculus books give you graphs that are too sloppy or like imprecise that you can't quite figure out something you want, so you kind of have to guess a little bit, but I try not to do that to you. Anyway, thanks guys. Please do try the homework. Bring back questions tomorrow.